This is Anthony Manning, and this is for the physics final. This is question 2, and we are given that a rock is sliding down a hill at a set acceleration and a set angle. And as it's going down this hill, there's a friction force acting against it, and the normal force at mass times gravity and the direction that it's actually moving in. I first start by trying to solve for the coefficient of this friction, and I do so by setting up all of the forces acting on it. I divide out the mass, and then I plug in all of the numbers that were given, and when solving for the coefficient, I get a 2.06, and that's the coefficient of friction that's acting on the rock as it's going down that hill. Wind then blows it back up the hill and causes it to stop, so its acceleration should be 0. And as that happens, this will cause the total force on this side to become 0, and then we can solve for what's the viscous drag of the wind itself. So when solving for, we move like this entire part to the other side and then divide off the remaining coefficients, and we end up with about 5.78, which is the coefficient of the viscous drag for the wind acting on the rock as it's stopping it in that instant. The last part of this would be to find the acceleration after the wind stops. So what would the acceleration be as the wind is no longer acting on it? And both sides have mass, and the only thing acting on it at this point would be the mass, the gravity, and the angle that it's at. So just divide off the masses and then solve for the acceleration, and I get 4.9 meters per second squared. Thank you.